To better illustrate the original parts of EISPP, I chose 4 categories: user interface, data layer, transport layer, and real-world production. This may not be what is needed when it is fully built out, but perhaps it is a start. One part of EISPP is a discovery tool. There needs to be a way to find information about products and people and how they collaborate. EISPP, as it was envisioned, falls with having the most utilized data stored locally with access to remote data containing more information about our products, people, and their collaboration as needed. It was thought that a natural language query interface fitting in the user interface and data layer categories would be the best way to access this information with no prior knowledge of the data structure. The query interface based on Power Aqua would utilize semantic web technologies, allowing for data composability and enhanced query results, utilizing and returning ontologies as well as instances thereof for a dynamic marketplace. Ontologies utilized for the data can be used to further comb through the data once the ontologies are known. Enrico Franconi et al. Introduced an ontology browser that can perform this feature. Sparkle, while possibly not a good choice if nothing is known about the underlying data being perused, is included to extend the query result. It is expected that as a consequence of using semantic web technologies, that the data will be represented as linked data that will be discoverable within and bridging between remote and local data. This leads to interest in a linked data browser. The Finfire project from Simile seemed like a good example. Faceted browsing allows for refinement of the data results based on certain triple patterns in the graph. Next comes stylizing the data because it is not always easy to read. This is like the previous things mentioned. It fits in the user interface and data layer categories. OPM, or Object Process Methodology, is possibly the most advanced stylization. OPM creates a layer on top of the data that is both machine and human understandable. GSS URI Sparkle and Fresnel GSS both use graph style sheets to stylize the presentation of the data by means of things like shapes and colors. Preferences allow for further refinement by changing the layout algorithm, modifying the graph style sheet, and adding further customizations. Data describing products and people and organizations might be done automatically or semi-automatically today using AI with ActiveGenLink as a possible example, but editing with less automation may also be important. Methods include adding a second file with graph data. Of course, NLP edit with ActiveGenLink was already talked about, manual editing of triples, and VRM. VRM is the most advanced and functions as a place to collect query data and save it locally, access and see an overview of local data, merge data graphs with different algorithms if desired, load badges, which could be verifiable credentials extended with cryptography, and possibly a ledger, load profiles and groups, modify access control for data, use a wallet to transact with data objects, and add additional data like for issuance, certificates, and supporting parties. Applications also generate data, which includes the metadata describing the projects that is presented as graph data, as well as the files such as for 3D printing or circuit layout. Ripple transaction falls in the user interface, data layer, and transport layer categories and provides a mean for payments based on contribution to value networks producing products and services. Other payment mechanisms could be used instead. BotQ IoT is a means to achieve distributed production. It falls in the user interface, data layer, real-world production, and perhaps transport layer categories. P2P Arc offers distributed compute power for applications to develop product and offer services. Aggregation of data describes the algorithms that get data where it is needed to be consumed in a timely manner. I went back to my research in P2P World OS, a P2P enterprise platform, and 3 resources struck out at me: Inga, Swarm Lambda, and Dentler's Semantic Web Reasoning by Swarm Intelligence. Inga focuses on optimizing the routing for querying of the data in a peer-to-peer space. It keeps track of peers that provide or assist with answers or are most connected to other peers. While Inga does its work or is dormant, I expect the ants to always be marching with the help of Swarm Lambda and Dentler's addition. That is, things like ants will be providing swarm intelligence that will be responsible for clustering similar data tuples and reasoning to add additional tuples for semantic closure and associative memories. I know this could be done better. While this is not expected to be exhaustive, more thought needs to be put into merging aggregation of data with the querying of data sections. Deterministic mappings between subgraphs could be considered with applied category theory. Migration to content addressable data over location addressable data could be considered for greater data persistence. Property graph traversal languages like Gremlin could be further explored. Object-based access control over list-based access control could be considered. DIDCOM could be addressed for the IoT bot queue section for secure communication.